Dear students, now we are going to discuss about laser. Actually, laser is a short form of light amplification by stimulated emission of radiation. From this you can understand that the basic principle for laser is stimulated emission. This slide shows the important properties of laser. First property of laser, it is a highly monochromatic beam. That means laser has single wavelength. If the laser is in red color, then the wavelength of the laser will be in the range of 690 nanometer. Then coming to the second property of laser, it is a highly directional beam. That means the angle of divergence of laser is very small. Then third property, laser is a highly intense beam. Coming to the final fourth property, laser has high degree of coherence. That means the wave trains of laser will be in same phase. Now we are going to compare ordinary light with laser. If we take ordinary light, they are not coherent, whereas laser, they are highly coherent. And in the case of ordinary light, they are not directional, but laser is a highly directional beam. And ordinary light has less intensity, whereas laser, it is a highly intense beam. Example for ordinary light, light emitted from sun or any other lamp, whereas laser can be produced by devices like a CO2 laser device or helium neon laser device. For understanding the production of laser, we must know what is stimulated absorption, what is spontaneous emission, and what is stimulated emission. Here we are going to discuss about stimulated absorption. Actually, stimulated absorption is the process in which energy will be given to the atoms in the ground state. When energy is given to the atoms in the ground state, then these atoms can absorb that energy and they can go to excited state. So this phenomenon by which atoms in the ground state can absorb energy from the incident radiation so that they can go to excited state is called stimulated absorption. Here we are going to discuss about spontaneous emission. Actually, after excitation, excited atoms cannot stay in their excited state for longer time. They have to come to lower energy state. And if these excited atoms are able to go to lower energy state without using external energy, then that process is called spontaneous emission. And during this transition of atoms from the excited state to the lower energy state without using external energy, photons will be emitted. That means that the absorbed energy will be emitted as photons. And these photons obtained by means of spontaneous emission will not be in same phase. That means these photons are incoherent photons. So these photons emitted by means of spontaneous emission cannot form laser beam. Hence, spontaneous emission is not the basic principle for laser. So coming to the spontaneous emission, it is the phenomenon by which the excited atoms can go to lower energy state without using external energy by emitting incoherent photons. From this slide, we are going to understand what is stimulated emission. We know very well atoms after excitation cannot stay in their excited state for longer time and they have to come to low energy state. If those excited atoms are able to go to low energy state without using external energy by emitting incoherent photons, then that process is called spontaneous emission. Here is another possibility where the atoms in the excited state can be forced to go to low energy state with the help of some external energy. In this slide, we are able to see an atom in the excited state here. If this photon is made to collide with this atom, then the photon will make the atom in the excited state to go to low energy state. During the transition of this atom from the excited state to the low energy state, a photon is emitted. But here we are able to see two photons. and these two photons are in same phase. They are coherent photons. How did we get these two photons here? Here, one of the photon is emitted by the atom during its transition from the excited state to low energy state. Whatever the other photon, that other photon is nothing but the incident photon. So in this transition of one atom from the excited state to the low energy state, we got two photons where these two photons are in same phase. That means these two photons are coherent photons, and these coherent photons can give rise to laser. Thus, stimulated emission is the basic principle for laser. For producing laser, two conditions must be achieved. First condition, population inversion must be achieved. That means number of atoms in the excited state must be more when compared with the number of atoms in the ground state. This state is called population inversion, where we can have more number of atoms in the excited state when compared to number of atoms in the ground state. Second condition for producing laser, stimulated emission must be more predominant over spontaneous emission. That means rate of transition for stimulated emission must be more when compared with the rate of transition for spontaneous emissions. So these are the two conditions for producing laser. Coming to application of laser, laser has a lot of application. It can be used in the field of medical, it can be used in the field of industry. In industry, it can be used for laser cutting. Here we are able to see how laser can be used for making this type of design. Apart from that, laser can be used in communication industry. So here, laser is used to transfer data from one place to another place using optical fiber. That's the application of laser in the field of communication. Further, laser can be used in the field of medical for rectifying our eye power and also for removing gallbladder. Here we are able to see surgeons are removing a gallbladder by using laser surgery. Like this, laser can be used in medical field also. Thank you very much, students.